let's start here. We're recording. Good. Last time we finished with this. Problem here, and what were we doing? We were solving, in this case, a polynomial inequality. A polynomial inequality. So you have a polynomial function, and it was less than or greater than or whatever to some number in this case, right? We're going to go through these steps again. These steps, of course, will not be on the exam. These are hopefully for your instruction. Oh, by the way, before I go in here, let me actually hand back some homework I've had sitting up here. Let's see here real quick. You and who's this right here? It's not here. Okay, so the idea was you find places that it could change signs. And it changes signs where either the numerator equals 0 or the denominator equals 0. You remember the last section where the numerator equals 0 means a function crosses the x-axis. Now, these are not functions, but this expression will equal 0. This will equal 0. That will equal 0 when you have an x-intercept. Then you want to figure out where it's undefined. Now, a polynomial is defined everywhere, so that didn't apply in this case. It's going to apply later today. Okay, it's going to apply later today. And then we wound up with points at which you could change signs, -2 and 3. 2 points divides the number line into 3 intervals. You plug one point in from each of those intervals. We did here in the green. And you see if it's positive or negative. And the expression cannot change signs inside those intervals. It's got to keep the same sign for the entire interval because we've already accounted for places that it can change signs. Then we shaded in the one that satisfied the inequality. And we wrote that as a set, a solution set. If you're ever asked for a solution set, it's a set. Huh? If you're ever asked to find the solution set of an inequality, you express your answer as a set. Right? Don't say something like this. Don't do this. That may be true or descriptive or relevant to your problem, but it is not a set. So in here in the book, solution sets are expressed in set notation of some kind. If you're ever asked to graph the solution set, it's going to look like this. You can use either notation. I went through that last time. You can use either notation. Now, I wanted to go today and say, okay, we were going to solve this inequality up here. This one right here. This one, right? We were going to solve that. Right? If that were a function, it would look like this. We know how to graph that as a function. All right? We know how to graph that as a function. And so if we want to solve where this is less than 0, where is that function less than 0? Where is it below the x-axis? It's in this middle region here that it's below the x-axis. All right? It's below the x-axis. Right? And so you see that from -2 to +3 is where that expression is less than 0. So if you have a calculator, you can check your answers for these. Here's another one. We're going to go through this one a little quicker. Not quick, but quicker. Not as much review as the last time. Rule number one. Step number one, you take your expression, you take the right-hand side, set it equal to 0. So it's going to be 3x squared plus x minus 2 equal 0. Now, there are times, actually, here, let me change that. Yeah, okay. This has the same solution set as our original. There are times that after setting the right-hand side equal to 0, you need to do some simplifying. In fact, there's going to be a time here today we're going to be doing a lot of simplifying. Find points at which the left-hand side is either 0 or has a 0 in the denominator. So that means it's 0 or it's undefined. Now here we don't have a denominator, so it's not undefined anywhere. So we're going to solve 3x squared plus x minus 2 equal 0. And this gives us places where it could change sign. Right? So that's going to be what? Let's see here. 3x, x, let me see here, plus 1 minus 2. Does that work? It may not work, but multiply it out. 3x squared, SCF, check. Positive 3x minus 2x is positive 1x, check. And minus 2 times 1 is minus 2, check. So it does work. You set each one of these equal to 0. You're either going to have 3x minus 2 equals 0, or x equal 2/3, or you're going to have x equal minus 1. Those are the solutions to this quadratic equation. They are the places at which it can change signs. Now, if you paid attention to the last slide, you know that it will change signs there. Something else I didn't mention here before is we checked up here whether it was positive or negative. We plugged in 1 point in every interval. Just like before, this 3, for example, where did it come from? It came from this term, or this factor, x minus 3. X minus 3. All right? That x minus 3 is to the first power. I mentioned this last time, so I see the 1s there. So you have the x minus 3 is to the first power. First power is odd. So you know it's going to change signs at that minus 3, from minus to plus. And this tells you another reason why it's going to change signs, because a quadratic is a quadratic that that has this shape changes signs at each of its x-intercepts. And so you plot those on the number line, minus 2/3, minus 1 and positive 2/3. These are points that make it equal to 0. They may or may not wind up in our solution set. Last time they did not wind up in our solution set. All right? So go here, and you're going to have minus 1, 2/3. These are places that equal 0. What do you do here? 2 points divides the x-axis into 3 intervals. 3 intervals. You pick a point from inside each interval to see if it results in a positive or a negative. So our expression here is 3x squared plus x minus 2. So we're going to check 3x squared plus x minus 2. So we're going to pick a point in each interval. Let's say we pick minus 2. Always pick 0 because it's easy to plug in if it's inside the interval. If 0 is one of the points, the endpoints, you can't pick 0 because you already know that equals 0 there. And then up here, you're going to pick, say, 1. We're going to plug those in, this expression here, and see its sign. Gotta look for the signs, right? Gotta look for the signs. Very important. So we're gonna have 3 times minus 2 squared plus minus 2 minus 2 that's going to be 3 times 4 minus 2 minus 2. That is 8, which is positive. So here, in this whole interval, the function is positive. If it's positive at one point, it's positive at every point in that interval, because it cannot change signs within these intervals. We okay on that? Question? 0 is easy to plug in, right? You're going to get 3 times 0 squared plus 0 minus 2 equals minus 2, which is less than 0. So it is negative in the middle. See, you see that this right here is a parabola opening upward. So you would expect the pattern to be plus minus plus. If it equals 0 at all. It's possible for quadratic to be positive everywhere or negative everywhere. So here, in the last interval, 3 times 1 squared minus, or excuse me, a plus 1 minus 2. That is 3 plus 1 minus 2 is 2, which is, of course, positive. And so that is positive in that interval. Now, for what values of x is the inequality satisfied? We go up here. I'm actually going to change things around a bit. I'm going to add something to the slide, actually. You're looking to where that is satisfied. I need places where it's greater than 0, or I need places, in this case, where it equals 0. So I see it's greater than 0 out here. It's equal to 0 at minus 1. Negative in the middle, so that's not going to be part of our solution set. Equal to 0 at 2/3. Positive after that. So I need the places where it's positive or 0. And so that's going to be what? It's going to look like this. Let's get minus 1, 2/3. And our graph's going to look like what? I need minus 1 to be part of my solution set. Why? Because that makes it equal to 0, and places that make it equal to 0 solve this inequality. Let me say that again. I need minus 1 in my solution set. Why? Because that makes the inequality, that produces that makes the left side equal to 0, and places where it equals to 0 satisfies that inequality. So it should be in the solution set. So this time, instead of doing this like I did last time, I'm going to write a square bracket indicating that point is included. And then I need over here, you see where it's positive right here? I am going to go to the left. You must shade in. You've got to shade that area, right? By the way, when people do stuff like this, I don't know what that means. Are you including that endpoint or not? So this, no bueno. Sometimes people leave that for their answers. I don't know what that means. That's not, no. That's not speaking math, right? Over here, we need 2/3 included because it equals 0 at 2/3. And we need to shade everything above 2/3. Okay? Your graph should be on the number line, not above or below it. Okay? Questions on that part? Now, this is the graph of the solution set. That's graph of solution set. What is the solution set? The solution set is the set of those red shaded numbers on the number line. All right. The solution set is going to be where? How do I describe this left-hand shaded area? It goes all the way back to negative infinity. It keeps going to the left. So it's going to be on the left, minus infinity, comma, up to and including -1. So it's going to be -1 square bracket. The set on the right, it starts at 2/3 with a square bracket, and it goes all the way to positive infinity. Notice positive infinity and negative infinity always get the rounded parenthesis, never the square bracket. They are not a number. They're sort of a concept, right? So it's not, there's not a number out there called infinity. And in the middle, you've got to say this or that. This or that. The way you do that with sets is the union. You've got to have that union sign in the middle. And so this is the solution set. All right? That is the solution set. All right? Any questions? The same 6 steps. 5 steps, excuse me. What was the difference in this one from the last one? This one had greater than instead of less than in the initial problem, had a greater than. It also included the equal to. So the equal to gave us these square brackets in this case. When it's an equal to, you may not have all square brackets. You've got to keep track of what's happening at those points. For example, at these 2 points, they were both equal to 0, and so they're included. We have an example coming up where some will be included and some will not be. All right, so the process is you find places that it can change signs, which is in step 2. You mark those places on your number line, step 3. These are places that it can change signs. It may not, but it can. It did in this case. You pick a point from each of those intervals. And once again, since these 2 factors are both to the first power, you expect it to change signs at both of those points. And it did. It did. So you pick a point within each interval, plug in the point into our expression over here. You got positive, negative, positive. All right? And so for your solution, you are interested in finding where is it positive or 0. And it's positive or 0 everywhere but in the middle. So from -1 to negative infinity and positive 2/3 to positive infinity. You shade that in. Your graph is on the number line, not above it or whatever that is, okay? All right, and then be able to describe the solution set as a set. And it has to have this union in the middle, right? Moving on. Okay, all right. What is key to this procedure and the last procedure? You remember when we were graphing rational functions? There was a spot where you plugged in points strategically to see if they were positive or negative. You got to see the sign. You got to see the sign. All right, here we go. This is stupid. This is really, really stupid. Ready? Okay. Oh, come on. That. They used to not give us ads in our channel. You want to know what my generation was dancing to in college? Actually, this is after my college. Yeah. You see the sign? Got to see the sign. Got to look for the sign. Ooh, yes. Okay. All right. Okay. I realize you cannot. Some things you cannot unsee. All right. Yeah. Okay. And seeing a 60-something-year-old math professor try, that's just. I won't even call it dance moves. Them weren't dance moves, Mr. Miller. Whatever that was, they weren't dance moves. Gotta see the sign. This one's going to keep us busy. Okay. We have this time it's a rational expression on the left. A rational expression on the left. I'll wait all semester to do that. Okay. That's stupid. This means these steps are going to be a little more involved. And you're going to have to do some algebra. I know it's college algebra, but sometimes people are surprised. All right. You're going to have to do some algebra. Set the right-hand side equal to 0, and the work is going to come in simplifying. So, set the right-hand side equal to 0, 2x minus 5, x squared minus 4, put the 1 on the left, minus 1 is greater than or equal to 0. That was easy. The next step we're going to do is we're going to find points at which this equals 0 or is undefined. You cannot look at that and tell me where it equals 0. You might be able to tell me where it's undefined. Because you see down here, we have a quadratic in the denominator. So where that quadratic is 0, this is going to be undefined. The problem is you can't tell me where it equals to 0. So we can't get to the points we need in step 2 unless we perform this subtraction. In other words, simplify. All right? This is messed up a lot on exams. And the miraculous thing is that people turn in perfect homework on this and yet can't do it on an exam. So be sure in the homework, number one, that you're doing the homework, right? I'm aware that there are websites you can plug stuff like this in, and it will not only get you this answer, it will give you all the steps. It will show you the work. There's websites out there. In fact, I have them on the course webpage. I encourage you to use them as learning tools. Right here on the Canvas, we have, actually I don't have them here. I'll put them there. One place is called Simple Lab. It'll show you the work. Some of these now have gone premium. Another one is called Wolfram Alpha, one of the most powerful websites anywhere on the web. Well, from alpha, I'll put them up there. They will show you work. I think you got to go premium for some of it, okay? Anyway, so we're going to perform this subtraction so we can find out where the numerator, where the expression, the left-hand side is 0. We know where it's going to be undefined, where this denominator is 0, but we don't know where the left-hand side is 0. So to perform that subtraction, you're going to have 2x minus 5. You need to get a common denominator, x squared minus 4. We're going to write minus 1 as minus, and we're going to write 1 as this. We need x squared minus 4 in the denominator. Any questions on that? Because x squared minus 4 is our common denominator. And so we're going to rewrite 1 as x squared minus 4 divided by x squared minus 4. Notice that equals 1. All right? And that's going to be greater than or equal to 0. Now let me show you something. Let's suppose it was a different problem. And I probably ought to change this problem, in fact. Let's suppose, don't write this on your paper because I'm going to erase what I'm about to put up. Let's suppose this were a 2 here. Suppose that were a 2. This would be a 2 here. What you would do is you would do 2 times that numerator if it were different than 1. Because you see the green is still equal to 1. So we're still 2 times 1. All right? So if that were a number different than 1, which it happens to be here, you just follow that all the way down. And now you would have to distribute that minus 2. That would have to be distributed over x squared and minus 4. All right. Okay. So our next step is going to give us what? I have a common denominator, x squared minus 4. 2x minus 5. I'm about to make a mistake. Somebody tell me my mistake. Minus x squared minus 4. Greater than or equal to 0. I made a mistake. What's the mistake?
Can't you just cancel the x squared minus 4?
You can cancel what, these? Or here?
Over there. The bottom.
You mean this cancels with that? Oh, no. When you add fractions, you get a common denominator. You don't add on the bottom and add across the top. No. If you have a over b plus c over d, you've got to get a common denominator. It's going to be bd. So you got to do top and bottom here by d to get bd. You get top and bottom here by b to get bd. So you're going to have bd in the bottom, and you're going to have ad plus cb in the top. But these bottoms definitely don't cancel if it's a no. You don't add on the top and add on the bottom. So that's not my mistake. Does somebody see my mistake here? Because I made the most common mistake I see on exams right here.
I don't know if it's because the minus is in the middle with the 14.
Now you need to hear this woman. She's speaking wisdom. What I heard her say is this minus has to be distributed. So the minus goes to the x squared, makes a minus x squared. The minus also goes to minus 4. Think of this as like a minus 1 out here. A minus 1 times the minus 4 gives you a plus 4. That is a super common mistake there, right? And so when I see places that people make common mistakes, I like to make a big deal out of them in class, right? So here, there's where we're at now. Whatever you do, here's another mistake people make. Right? They get 4, 4. It cancels. Every time you do that, a kitten dies. Somewhere a kitten. No. You can't cancel terms. You can only cancel factors. So for example, if I have over here 5 plus 3 divided by 3, if I cancel those 3's, that would equal 5. But if I did it properly, 5 plus 3 over 3 is 8 over 3. This is correct. This is not. You can't cancel those 3's. They are terms. You can only cancel factors. Things that are where the top and bottom are multiplied by the same thing. You can cancel that thing. So now here, what do we have? I'm going to move this over just a little bit. Move all that over. More. Okay. And then we're going to go from here up here. What's the top equal? 2x. Look at this. 2x. I want to write this as a polynomial. So I have 2x minus 5 minus x squared. So that's going to be a minus x squared. How many x's? 2x. What's my constant? Minus 5 plus 4 minus 1 divided by x squared minus 4. Right? And that's greater than or equal to 0. I told you we had some work ahead, right? Now, if you're smart enough, go ahead and factor. We got to figure out where the top and bottom is 0. If you're smart enough, go ahead. Now, what I would do is I would write this numerator like this. I would factor off that negative. That negative up front throws people off. Factor off a negative and make that x squared minus 2x plus 1. So that's going to give us negative x squared minus 2x plus 1 divided by x squared minus 4 greater than or equal to 0. Oh, keep in mind that if you're doing your algebra right, all of these have the same solution. All of these have the same solution. Right? So all of these have the same solution as our original problem. If you're doing your algebra right, you have not changed the solution set. Now, watch this. Very, very important. Ready? This right here equals x minus 1 squared. Right? That factors in the top. So we're going to have x minus 1 squared in the top divided by, what is the bottom? What does the bottom factor into? X squared minus 4? You know 12 ways of factoring a quadratic equation. What you should recognize here is x squared minus 4 is a difference of squares. X squared is a perfect square, 4 is a perfect square. So this is going to be x plus 2, x minus 2. Greater than or equal to 0. So there we factored. Because remember our point, in our next step, we need to figure out where this equals 0 or it is undefined. We have one more thing to do, though. You see this rascally little minus sign out here? Let's get rid of it. We're going to multiply both sides by minus 1. And that will get rid of that minus sign. And it's going to flip the direction of the inequality. We multiplied by minus 1. Every time you multiply by a negative number or divide by a negative number, the direction of the inequality flips. Okay. So we did a little bit of algebra and college algebra today. All right. What was worse, that or the professor's? No. Question. I'm supposed to put here in the next step points at which this left side, right here is the left-hand side now, right? Left-hand side. Place where that equals 0 or places it is undefined. Where does it equal 0? It's going to equal 0 where the numerator is 0. So you have x minus 1 squared equals 0. That's x equal to 1. Right? That's the numerator. Or where there's a 0 in the denominator. X plus 2 times x minus 2 equal to 0. The zero product rule. Very first example of class, of the whole semester. Zero product rule. Products equal 0. This means x plus 2 equals 0, or x minus 2 equals 0. X equal minus 2, x equal plus 2. That's why you did all that algebra up there. Because you remember I told you before at the beginning, we don't know, we didn't know where this equaled 0. We could tell where it was undefined, but we didn't know where it was equal to 0. In order to figure that out, we had to go through this process and make this a rational expression on the left. What's a rational expression? One polynomial over another. Up here in the yellow, I don't have a rational expression. I mean, I have one, but I'm subtracting 1 from it. All right. All right. What do we do? I want to make sure that's sunk in. These points, x equal 1, minus 2, and 2, those are the points at which you can change signs. These points, minus 1, minus 1, minus 2, positive 1, excuse me, minus 2, and 2, those are points at which you can change signs. You put them down here. But you're putting them down there now with a little bit of commentary. So we're going to have minus 2. We're going to have 1. And we're going to have 2. Now, you remember last time I told you to put above those what's happening there. So minus 2. This is a place that is a 0 in the denominator. So at minus 2, it is undefined. Right? At 2, it is undefined. And at 1, it equals 0. It is very important that you know the difference. It is very important that you know the difference. All right? Places where it's undefined will never be in a solution set. Never. Never, never, never. Places where it equals 0 could be in a solution set, just like the last example. All right. So now what are we going to do? We're going to pick a point in each interval. Minus 3, 0. We like to pick whole numbers, but this time we can't. Between 1 and 2, I got to pick a number in there. That's going to be 1.5. Call it 3 halves. And then I'm going to pick 3. Now, Now, this is where a little bit of wisdom can save you some work. We want to find out whether this expression here, x minus 1 squared divided by x plus 2, x minus 2, we need to find out whether that expression is positive or negative at those green points. Positive or negative at those green points. So we plug them in. Now, here, I'm going to approach this a little bit different. I can plug them in and get plus or minus at each one. Okay. We're going to do this a little different. How about if we plug in this 0? 0 is easy to plug in, right? Us bottom dwellers like things that are easy. So 0, when I plug in here, I'm going to get what? Okay. Plug in that, plug in 0. The top is going to be minus 1 squared is going to be 1. The bottom is going to be 2 times minus 2 minus 4, which is negative. So right here, in this interval here between minus 2 and positive 1, it is negative. All right. Okay there? Now, we're going to use a little bit of our reasoning. When I go from negative here, and I pass this point right here, minus 2, and I go over here, do I expect it to change signs here or not? Well, that minus 2 came from where? That came from this factor, x plus 2, which is to an odd, oh dear, my board just crashed. All right, my board just crashed. We're going to do this. All right, keep this checked out. We have here. And we have to reopen this. Software crashes after you've written on it too much. Usually I lose the entire page I've been working on, which is a lot of work here, isn't it? Let's see what happens here. Lot further down than that. Oh, we lost the entire page. Actually, here. Now that's going to replace a lot of it. All right. I'm sorry that is not going to be included. We lost this top part. Okay. Lost that top part, but we have that part. All right. Actually, down here, I need to be doing. I've kind of jumped. I'm doing steps 3 and 4 here on this last one. Okay. I'm sorry. We're just going to have to keep going. Right. Now watch what happens here. Watch what happens here. What I will do with slides, just so you have a good set of slides, if you want them, I'm going to go back and copy some work from last semester here, and that's what will go on up on Canvas. Okay. because we lost some data here. All right. But what I want you to understand is this minus 2, it was negative here. That minus 2 came from an x plus 2. That is to the first power. That means it will, that's odd, it will change signs here. So this right here will be a plus over here. You know it's going to be a plus. Now we're gonna plug that minus 3 in just to make sure, okay? Then over here, when we cross this 1, in this little interval between 1 and 2, will it be positive or negative? That 1 comes from the numerator, which is to a even power. So at 1, it's going to go from negative and stay negative. It will not change signs there. That's the first time we've had one that didn't change signs because it was to an even power. Right? And then over here, this 3, when we plug in 3, well, as it crosses this 2, positive 2, that positive 2 came from this x minus 2, which is to the first power. That's odd. So we expect over here this to change signs. This to change signs. All right. Now, what we did there, unfortunately, is I cannot copy most of that because of the crash we had. So what we're going to do is all that. Next page. That is actually here. Go here. All right. We evaluate that at one point there in each interval. Where is the inequality satisfied? The inequality we're seeking to satisfy. This crash came at a really bad time. Is this one here? So the inequality we're seeking to satisfy is this one right here. Is x minus 1 squared over x plus 2, x minus 2. And that was less than or equal to 0, I believe. Yeah, okay. Where was that satisfied? I need to know where that was negative or 0. It was satisfied where it's negative is in the middle here. It's 0 there, and it's negative. So it was satisfied from minus 2 over here to 2. It's positive out here, positive here, and at these two endpoints, it's undefined. So one thing simple about this problem is the solution set graph is that. And the solution set is just minus 2 to 2. All right? Sorry about that crash there at the end. That cost us some time. I don't want to go over, so I will leave it there. Nice weather. Get out and de-stress. Something outside.